Welcome viewers to the SD online classes. Without giving much introduction, I will continue from our previous class, that is there we were drawing the parts of the spherical mirrors. We already finished the first one, that is aperture, second one pole, third one center of curvature, fourth one radius of curvature, fifth principal axis and normal also. After that I thought the video is little lengthy. After about 10-11 minutes I am going to connect it with the new one, this one. Okay, let's start. The next one will be the important one, more it will be used. It is 7 here, it will be focus. Okay, so we'll write what is focus and then focal length and focal plane, those are also connected to focus only. So this is the focus. The focus is the ray traveling close and parallel axis. Okay, the ray traveling close and parallel to the principal axis, parallel here I missed, to the principal axis. We'll draw what it is, how it looks like, of a mirror after reflection from it. Okay, it either converges or diverges, it depends on the mirror. In the concave it will diverge, okay, it will converge, and in the case of your convex it will diverge. We'll show it with the example. The first one will be for concave. Okay, here what will happen after reflection, the light rays converge. Let's show how it is happening. Here I will write, this is the mirror. Now you have to be good in drawing it. P, X, Y, remember all the things. M was the aperture, P was the pole, X, Y is the principal axis. Now going to come the incident light coming here, right? When it is going to hit it, you can see that it is facing down, so it will be reflected back here. This is focus. Remember, do not confuse with the previous one. Okay, this is not reflecting, this is only dotted lines, it was not reflecting there. Here I will make the direction also, it is reflecting coming here. So the point where it meets is the focus. And interesting with focus is that it is half of the center of curvature. This is half of this. Okay, if you pass another line like this, again a parallel line like this, it will also come back exactly here. This is the nature of the mirror. Every mirror it will happen. Go here, while coming back it will come here. Okay, I'll not draw one more because it will look very untidy here. So this is how it is happening. So this is in case of concave. For convex, after reflection, what is happening? Appear to diverge. What is appear to diverge? You will understand in this diagram. Let me show. This is the convex mirror. M and M is the size of the mirror. You remember what was this? Straight line, of course. X, Y is the principal axis. This is the pole. Okay, light will come always from left side. You will show always left side. This is sign convention. And then it will not go, because mirror cannot penetrate. Okay, so it will look like it is going here, but actually what will happen, it will go here. Understand, because inside the mirror it cannot go, there is nothing inside, isn't it? So now what will happen, it will come back, but it will look like it is going. That's why it has to be drawn like this. So this is your focus. Remember this focus, and I told you one rule there, this center, this Y you can draw somewhere here, this Fy and Fp is equal. Okay, another line, let me make it here, parallel line, straight parallel line, okay. It will also go here, look like it is going there, but it is going here. You can see what is diverging means going away is called diverging, okay. The light is going away from here, okay, not at one point. Here light is going and meeting at one point, converge. Converging is this property, meeting it and finishing it. Diverge means going away. Look at from here, it is going away. This is called diverging. So after reflection appear to diverge. After reflection it actually converge. Here it is not converging, not diverge, it is appear to diverge, okay, appear to diverge, and that is why it is happening, okay. So this is how you can do the focus. The next will be number 8, that is focal length. It is also connected to focus, okay. So how it is done, let me show. Let's see it quickly. Here it is the focal length. Focal length is the distance from the pole of the mirror to the focal point, or you can call focal point and focus is same, okay, f already. So f is pf. If you see the diagram, you will understand what I am saying here. This was your concave mirror. This is like this, pole, size of the aperture, the size of the mirror here. You have center here. This is x, y principal axis. This will be your focus, okay. Now this distance from here to here, it is fp. Remember, this was for your just reference, no need to write actually here. From here to here, it is r, and you remember it was double, so that is why f is equal to r by 2, okay. This is called focal length. Don't confuse with small f and capital F. Capital F is the point, this point, name of the point. Small f is the distance, fp. Capital C is the center, capital R is the distance. Here both capital, there capital and small. Here in case of convex also it can happen, same thing. This is your convex mirror, principal axis, x, y is principal axis, pole, and here is the focus, somewhere double here, the center of curvature. Light will go, that I will not show here. The only important thing is this one. This is f, okay. This was I am saying, okay, not here. We already studied here, r. So this is for convex, this is for concave. We wanted to say what is focal length. What is focal length? Focal length is very important. It is the main property of a mirror. When you know the focal length, you will understand everything about the mirror, okay. Next is your focal plane. Let's understand, it's easy to understand. Focal plane, an imaginary vertical plane. It is not in real, you cannot see it. Through the principal focus and at right angle to the principal. Let's understand, through the principal axis means it is here, but how you can see, let's see. In case of concave mirror, it will be easier. Draw again and again so that you will understand. When you are learning also, you make it like this. M is aperture, P was pole, X, Y was principal axis, C was the center of curvature, here was the focal length, half, okay. Here, let's understand. You remember I told you the mirror is like this, okay, not a line, it is actually like this. Similarly, if I make a plywood here, plywood like a cardboard or any paper like this, okay, if I put it like this, that is called your focal plane. Now let us understand, it is a vertical plane. Vertical means up down, not left right is called horizontal, vertical is up down. And at the focus, through the focus means at the focus, and at right angle to the principal axis. This is principal axis, remember xy is what? Principal axis. So the focus, the plane will be perpendicular. Can you see perpendicular? So this is the focal plane, okay. So this is called focal plane. In this case also you can make it here. In this case also, this is the convex mirror, pole, aperture mm dash, x, y is the principal axis, C is the center of curvature, F is the focus, and at the focus if I make a wall, okay, like this, remember your mirror was like this, okay, this is the shape of the mirror here, it is not line, I am repeatedly telling you. So if you put one screen here like this, okay, so that will be called your focal plane. Why focal plane? Because it is at the focus, that's all, okay. And why it is a plane? Plane is not a line, it has to be like this, okay, a surface, it has to be a surface, and that has to be perpendicular with the principal axis. So perpendicular to principal axis is like this, because this is the principal axis direction, this is the principal axis direction. Here you will make this, okay. This is your things that we introduced for lens, for mirrors.